discovered free-floating planets similar to Earth. We don't know if we are alone or not in the universe, but we can say at least we are trying to figure it out. That's why astronomers are making a lot of effort in order to discover and study new planets similar to Earth called exoplanets. Nowadays, we have a bunch of methods to investigate the nature and existence of these planets around their host star. But now, using data obtained in 2016 by NASA's Kepler Space Telescope, a team of scientists discovered a population of planets floating in space. These planets are not gravitationally bound to any host star, and 4 of them seem to have pretty much the same mass as our Earth. But what does it mean they're a free-floating planet? Where is their host star, and how did they find them? Keep watching the video to get to know the answer to these questions and more. If you'd like to help improve the quality of our content, please check out the Patreon link below. We would like to say a big thank you to all those who show their support. Nowadays, the word recycling is a very important one because the world needs to limit waste. Recycling could be done in various areas, even in the field of astronomy, and that's exactly what happened. A team of astronomers decided to take an instrument and adapt it to an unscheduled use. We're talking about the famous Kepler Space Telescope, NASA's first planet hunter. The study was led by Ian MacDonald from the University of Manchester. The purpose of the team was to readapt the Kepler telescope to be able to capture a subtle relativistic effect called microlensing to see if they would find something. And they did. They discovered a population of floating planets in space. 4 of them would have masses similar to that of the Earth. This is what we know about free-floating planets in our Milky Way. First, a rogue planet, also termed an interstellar, nomad, free-floating, unbound, orphan, wandering, starless, or sunless planet, is a planetary mass object that does not orbit a star. Such objects have been ejected from the planetary system in which they formed or have never been gravitationally bound to any star or brown dwarf. The Milky Way alone may have billions to trillions of rogue planets, a range which the upcoming Nancy Grace Roman Space Telescope will likely be able to narrow down. Second, astronomers observed 50 million stars in the Milky Way by using the 1.8-meter, 5'11" MOA-2 telescope at New Zealand's Mount John Observatory and the 1.3-meter, 4'3" University of Warsaw telescope at Chile's Las Campanas Observatory. They found 474 incidents of microlensing, 10 of which were brief enough to be planets of around Jupiter's size with no associated star in the immediate vicinity. But the most important thing is that the researchers estimated there are nearly 2 Jupiter-mass rogue planets for every star in the Milky Way. One study suggested a much larger number, up to 100,000 times more rogue planets than stars in the Milky Way, though the study encompassed hypothetical objects much smaller than Jupiter. However, a more recent study with 6 times larger statistics than the 2011 one indicates an upper limit on Jupiter mass free-floating or wide orbit planets of 0.25 planets per main sequence star in the Milky Way. Third, nearby rogue planet candidates include WISE 0855-0714 at a distance of 7.27 plus or minus 0.13 light years. In September 2020, astronomers using microlensing techniques reported the detection, for the first time, of an Earth-mass rogue planet. It was named Ogle 2016 BLG 1928, and it is unbounded to any star and free-floating in our galaxy. Floating planets may be the remnants of destroyed planetary systems or so-called failed stars, too light to trigger nuclear fusion reactions within them. Unfortunately, among these, only the very young and most massive planets are bright enough to be directly detected, while the identification of smaller ones is based on gravitational microlensing, a relativistic phenomenon that occurs, for example, when a planet crosses the line of view connecting an observer and a star in the background. The star's light appears temporarily brighter, a peak that can last from a few hours to a few days. In short terms, it's a bit like we're wearing a pair of glasses, says Catherine Trott, president of the Astronomical Society of Australia. Just like a normal lens in your glasses can bend light to focus things, large masses like galaxies can do exactly the same thing. That's general lensing, she says. Microlensing is a tiny case of that. Instead of it being a galaxy doing the bending in this case, it's a small, low-mass object which we can't see, and therefore it's thought to be a planet. At any given moment, about 1 in a million stars in our galaxy is visible undergoing microlensing, but only in a small percentage of cases is the phenomenon caused by planets. According to the theory, the increase in brightness follows a characteristic timescale that depends on the mass of the object that acts as a lens, the distance between the observer, the lens, and the source, and the relative speed between the source and the lens. To observe this phenomenon, since relative speed and distances are generally unknown, we rely solely on the characteristic time of increase in brightness. In the case of floating planets, very short microlensing events are sought. As we said, the team used the data from the Kepler mission, and the observations were conducted from April to July of 2016. These observations were actually part of the second phase of the Kepler mission, also called K2. The K2 mission is a follow-on to the Kepler mission. It began when the original Kepler mission ended due to the loss of the second reaction wheel in 2011. The design of the K2 mission needed to periodically change the telescope's pointing to sample a variety of galactic sightlines to maintain reasonable pointing stability, balanced via the solar wind. While the mission continued to observe stars to detect transiting exoplanets, the variety of pointings enabled a wider variety of astrophysical research projects. In fact, the K2 mission was fully guest investigator-driven. By the way, in these 2 months, Kepler monitored a crowded field of millions of stars near the center of our galaxy, searching for some specific and typical signs that were extremely difficult to find, because the old recycled telescope pointed to one of the most densely crowded parts of the sky, where there are already thousands of bright stars that vary in brightness and thousands of asteroids that skim in the field. Astronomers tried to extract from the noise the tiny variations in brightness caused by the planets, having only one chance to see a signal before it disappeared. Kepler was not designed to observe such dense star fields nor to find planets with this technique. But thanks to new data analysis methods, the researchers identified 27 short-lived microlensing signals that varied on timescales between 1 and 10 days. Of these, 22 had already been seen previously by large ground-based observation campaigns and were confirmed by the Space Telescope. The remaining 5 are new discoveries, and the 4 shorter events show a signal consistent with planets of similar mass to Earth. Furthermore, the new findings are not accompanied by a longer signal that would occur if they were linked to a host star, which supports the hypothesis that they are also wandering planets. The authors speculate that they originally formed around a star before being ejected due to gravitational interaction with other heavier planets in the system. Now that we've talked about this new discovery, why do you think it's an important one? Before answering this question, please be sure to like or dislike the video so that we can continue to improve and make these videos better for you, the viewer. Plus, be sure to subscribe to the channel by clicking the bell so that you don't miss any of our weekly videos. Well, the fact is that we can't see the planets directly. We could just infer their presence because we see their traces, i.e. their gravitational effects on their surroundings. Confirming the existence and nature of these rogue planets will be a major focus for upcoming missions like the NASA Nancy Grace Roman Space Telescope. Also, they might be a very interesting source of information because we usually expect planets to be bound to a host star. If we found objects that are not bound, then either they're planets that have been ejected from their planetary system, or they're small, failed stars, so objects that weren't quite massive enough to actually ignite a star. This means that we are dealing with this as a whole new population of objects, planetary objects that we didn't know existed before. That's the actual importance of this discovery. Okay, we found evidence for the presence of these objects, and we are very excited about that. But what will happen next? Kepler has succeeded in what it was never designed to do, providing further evidence for the existence of a population of free-floating Earth-mass planets. Now, Kepler passes the baton to other missions that will be designed to find such elusive signals that Einstein himself thought it unlikely that they would ever be observed. I am thrilled that ESA's upcoming Euclid mission can join this effort as an additional scientific activity to its core mission. Also studying this new type of object, astrophysicists found that under specific conditions, these planets' moons are able to retain an atmosphere capable of ensuring the long-term thermal stability of liquid water on their surface. This means that liquid water can be formed on the surface of the exomoon. Can you imagine that? Also, scientists say that the final amount of water for an Earth mass exomoon is smaller than the amount of water in Earth's oceans, but enough to host the potential development of primordial life. This is another important thing about free-floating planets. We are pretty sure we'll be talking a lot about exomoons, exoplanets, and the searching for life as we know it over the next few years. We just have to wait and remember to keep it curious. That's all for this video. Thanks for watching, everyone. What do you think about rogue planets? Let us know in the comments below. And please remember to share the video if you liked it. That's a great way to help us here at the channel.